So welcome again to another session of our focus on trigonometry. This time we are still on the regular season set of questions. We move forward to question 13, which is the integral of sine x minus sine x nested minus sine x nested in the second sine x, and that continues all the way to infinite number of sines, and that is from 0 to pi over 2 plus 1. So this is a very interesting problem, and yeah, it's one of those very complex problems that it's even very hard to use online tools or software to try and solve it. Before we begin, quick encouragement to those of you who are here for the very first time, or those of you who have been following us but haven't subscribed, to subscribe. For every time we come up with a solution, if you've subscribed, you'll get a notification. So how do you go about solving this? The first thing we'll do is to let u be equal to the function, the integrand. And what you observe is that what is also nested in after x minus is also similar. It's the same as u. So we can now summarize our integrand as u is equals to sine x minus u. Now that means that the arcsine of u is equals to x minus u, and if we make x the subject, x is the same as u plus arcsine of u. Okay, so I think up to that point we are very clear. Now since we figured out that x is the same as u plus the arcsine of u, if we look at the limits, when x is equals to 0, that means that both the u here and also within the arcsine of u should be equal to 0. Now when x is equals to pi over 2 plus 1, it means that this u at this position here is 1, and also the u in the arcsine function is 1, such that the result of the arcsine of 1 is pi over 2, and the result of adding that extra u gives you pi over 2 plus 1. So u ought to be 1. So when we now go forward to differentiate dx with respect to u, first dx du at that first position is 1 plus the derivative with respect to u of arcsine of u. Now to differentiate arcsine of u, the way we would probably go and do it is to suppose that y is equals to arcsine of u, and therefore sine of y is equals to u, and so cosine y dy du is equals to 1. And that means that dy du is equals to 1 over cosine y, and cosine y is the same as the square root of 1 minus sine squared y. Okay, and that means that dy du is the same as 1 over square root of 1 minus u squared, since sine y is the same as u. And so this derivative of arcsine of u is the same as 1 over square root of 1 minus u squared. So dx du is 1 plus 1 over square root of u squared, and therefore dx is the same as, in bracket, 1 plus 1 over 1 over square root of 1 minus u squared du. And so our original integral of sine x minus sine x minus sine x all the way to infinity from 0 to pi over 2 plus 1 is the same as we can substitute u for this complicated integrand, and then we can also substitute for the limits and also for dx. And so that leads us to the integral of u times into bracket 1 plus 1 over square root of 1 minus u squared du, where this here originates from dx, right? And the limits, as you saw, we're able to transform that in a clear way, and then the integrand is the same as u. And so that means it's now the integral of u plus u over square root of 1 minus u squared du. Right? Now, we can separate that into two separate integrals where we can keep the first integral as it is, and then in order to make things a little bit simpler, we can substitute for u in the second integral by letting u be equals to sine theta. And so transforming the limits, when u is equals to 0, theta is 0 because sine of u is which is 0, sine of 0 is 0. And then when u is equals to 1, the sine of 1 is pi over 2. So also du is equals to cos theta d theta. And our integrals now is in terms of u and also in terms of theta. The first one will remain as it is, the integral of u, and the second one will be sine theta over square root of 1 minus sine squared theta times cos theta d theta in place of du here. And so simplifying the second integral, 1 minus sine squared theta is the same as cos squared theta. The square root of cos squared theta is cos theta. And so the cos theta in the denominator and the cos theta in the numerator, they do cancel. And so we are left in the second integral with the integration of sine theta from 0 to pi over 2. And obviously the first integral is u squared over 2 with the limits 0 and 1. And the second integral now results into negative cos theta from 0 to pi over 2. So what that means is that now we have substituting in for the upper limit is 1 over 2 because 1 squared over 2 is the same as 1 over 2, and then 0. So a half minus 0, the second integral is obviously negative cos pi over 2 minus negative cos 0. These two negatives here results into a positive. Cos of 0 is 1, cos of pi over 2 is 0, and so we have a half plus 1, which results into 3 over 2. And that is our answer. Well, the question was a little bit tricky, but I think with the sum of the transformations that we're able to put in place, I think made it a little bit more tractable. Again, an encouragement to those of you who have not subscribed to our channel, please subscribe because we're going to try to solve these very complicated problems, and some of them have very interesting solutions. And each time we do that, we promise that we'll try to send notifications your way. So thank you so much, and until we solve the next problem, it was great hanging out with you as we solve this problem. Thank you.